Hello, students. Guess who this is? That's correct. This is your professor, Dr. Mink. Good guess. This is the first of two lectures for Chapter 3, and we will be delving even deeper into the world of programming. We will begin discussing variables and calculations. A variable is a storage location that holds data, and most calculations require the use of variables and constants, but we will drill down at a very high level of detail throughout this lecture. So let's get started. Here are the topics covered in Chapter 3. As I mentioned earlier, I break each chapter into 2 audio lectures, and we're going to get through section 3.5, formatting numbers and dates, because when we start talking about classes, class level variable, that's a very significant conversation. And I'd like to start off our next lecture with that. So we're going to talk about text input, variables that can store that input, and the different data types of variables. And then we will start to perform basic calculations, calculations will use both constants and variable data. We are going to mix different data types, and once again, we're going to drill down on each one of these topics, which is covered in a section in the textbook. And we'll finish with formatting numbers and dates. That's always challenging. And then next week, we'll begin with class level variables and the rest of the topics for Chapter 3. First up, material from section 3.1, gathering text input. Let's step back from the contents of the textbook for a second and talk about an interaction I know all of us have had with a computer program, or I'm assuming all of us had. I know I've done this hundreds of times. That is, I walk up to an ATM to get some cash or to perform a transaction. What's the first thing that I'm asked from the program running on the ATM? And don't fool yourself, there's a computer program, it's running constantly on that ATM. First thing it asks me for is my card. It wants me to swipe my card. It's asking, or it's soliciting input from the user. What's the input device? The magnetic card reader. What is the input? It's my account number and routing number for my bank and all that stuff, all that data that's encoded on the magnetic strip. So I swipe that, and it reads that input and stores it into variables that hold that information, that data. Next thing it asks me is to enter a PIN, my PIN, personal identification number. And that is stored in a variable. And then there's some processing that takes place. And I can tell you behind the scenes what happens. It goes out to the network, gets my bank account number, and that bank account number has a PIN stored with it. So it compares the PIN I just entered to the PIN stored in my account, in the database that stores my account information. If they don't match, guess what? We're not going any further. It's going to give you some sort of message that you entered an incorrect PIN. I believe it gives you 3 attempts and then it locks your account. So text input is of great importance in the types of programs that we're going to be writing in this class. Let's take a closer look. Before we go any further, I want to make sure that you've already completed tutorial 3-1, which is greeting. The program's called Greetings. I put a video of that program running in the timeline for this week. so you can see the finished product and know what the goal is. But it's important that you've done that before we start to talk about the text box control. So if you haven't, pause this, go do it, come back. Okay, on to the text box control. A text box control is a rectangular area we place on a form that allows the user to enter input. And it's a very common input device, or input control, I should say. And you can solicit any type of input, numeric, alphanumeric, etc. And then there are some techniques for converting numbers from text, which is how it comes in, to their appropriate numeric format. And we'll talk about that later. As you might have guessed, the text property of the text box control is of great significance. And it can be accessed in code the same way you access any of the other properties. So here are a few examples on this slide. The first example takes the text property of a text box and assigns it to the text property of a label. In other words, take whatever was entered in the text box and assign it to the label. In this particular case, it's label info.text property. And that'll display in the label. The contents of the text property can also be displayed in a message box, which we covered in the last lecture. And that would be messagebox.show text input.text. Very simple. And if you, as I suggested, and I'm now really encouraging you to have finished tutorial 3.1 before you go through this. If not, this may not make a lot of sense. You should get this if you have already completed that tutorial. You often have to clear the text contents of a text box. And here we see two ways. There's actually a third way. First way, you can clear the text with an assignment statement. So here we have a text box. Its name is text input. And we're assigning string.empty, which is the empty string, to its text property. And string.empty is what's called a predefined constant. And it replaces whatever text was in text input with an empty string, which is empty, just zero, nothing. Not zero, just empty, no contents. We can also use a method, okay? Method is, it's a function, and it performs an action, and in this particular case, the method we're using is clear, and in the parentheses, there's nothing. That means there's no argument. And when we get to functions, this will become much clearer. No pun intended, because we're using the clear method. Text input dot clear. The member function clears the text property. I don't know if you caught it earlier in the lecture, but I used the word concatenation. Concatenate means to add together. And in this particular case, we're going to talk about string concatenation. So in the tutorial, the user enters their name into the text box text name. And then we have a label greeting in which we want to display hello as a string, okay? And we want to add the value stored in the text property for text name. So the way we do that is with an assignment statement, and we concatenate the string hello, and then we have a space. So it's H-E-L, capital H-E-L-L-O space is the string, and then the and, or the ampersand. And we add to that the value, the string stored in text name.text. And that gets assigned to the text property for label greeting. And there is the line of code that accomplishes this task. It appends the username stored in text name.text to hello space and stores the results in label greetings text property, which in turn displays on the screen. Tutorial 3-2 shows how we can concatenate strings from multiple text boxes. And this particular tutorial is great, and I've posted a short video. You can take a look at it. So we enter the day of the week, the month, the day of the month, and the year into 4 different controls. And those values, those strings are stored in the text property. And then when we click on button show date, it executes an event handler that concatenates all those strings and assigns the compiled or totally concatenated string to label date string.text. Very cool and easy tutorial for you to complete that shows the power of concatenation. Please take a look at that tutorial, complete it, and that will make this part of the lecture so much easier to understand. You'll notice when you're working in design view and you drag a control either initially to a form or when you're moving it, these kind of subtle alignment lines come up, and you'll see blue guidelines for vertical alignment so that you can easily align it with adjacent controls, and then lavender. I don't even know what lavender is. I guess that's a color. It must be. A lavender guideline comes up to show you horizontal alignment. And the best way to see how this works is to try it. And we could talk about this until the cows come home, but you really need to try this. That brings us to section 3.2, which covers a very, very important topic, variables and data types. And we've talked a little bit about, or I've talked, you've listened, a little bit about variables so far. We're going to drill down in significant detail and describe what a variable is. It's a memory location, storage location in memory, and the different data types that can be stored as variables in memory. Whenever you enter data into a program, and let's go back to the ATM example I gave at the beginning of this lecture, that information or that data has to be stored before it can be used. So a variable is a storage location in memory used to hold information while the program is running. It's called a variable because it can change. The contents vary. So the user can enter it, it gets stored in a variable, and the program runs, and then a different user comes in or another run is executed and the same variable is used. So going back to the ATM example, the PIN, I've never seen the code for the ATM machine, but I can, with a high level of confidence, tell you pretty much what it looks like. There's a variable in there. It might even be called PIN, P-I-M, or customer PIN, or whatever the programmer named it. And when I step up and it asks me for my PIN, and let's just assume my PIN is 1234, and I type in 1234, during that execution of the program, PIN holds the value 1234. And when I exit and walk away from that, and someone else comes in and it starts over asking for their card and then their PIN, it's the same exact storage location used to store their PIN, just a different run, and it authenticates that PIN against the PIN stored in the database for that account number. But it's a storage location that's used over and over and over and over again, thus the term variable. This slide lists some of the primary uses of variables. With variables, you can copy and store values entered by the user and manipulate those values. Obviously, we can perform arithmetic operations on variables. We can mix variables and constants in arithmetic operations. Testing values using Boolean conditions, and that's a term that should not be familiar to you at this, or probably is not familiar to you at this point in time, but we can test. So for example, the PIN variable entered in the ATM example I gave earlier. You're going to compare that value, the one entered at the ATM, to the PIN stored in the database record associated with the account number on the magnetic card. Temporarily hold and manipulate the value of a control property with a variable, and we can remember information for later use in the program. Here's a concept that initially students often struggle with. They see variables in a program and they don't recognize the fact that that is not a keyword. So in our programs, you're going to create variables, and I want you to understand you own the name for the variable. You decide what the variable is called. There is no exact science to this. Now, obviously, we want to use names that are intuitive, that make sense. But when you create a variable, declare a variable, you have to give it a name, and that name associates or that's how you reference the storage location in the computer's memory. And the value currently associated with the variable is stored in that memory location. So whatever the current value is, that's stored in the memory location that's referenced by the name you give it. At the end of the day, there's going to be a hexadecimal memory location generated by the compiler. And that name that you give it is only used within the context of the program that you write. But the actual machine language code that runs through the CPU, and I'm getting way ahead of myself, but just know that that name is a reference for a memory location, and you designate the name, and it makes it easier for you to identify and use that memory location. In your program, you'll be declaring variables, and what that does is it sets aside space in memory to store specific types of data. So a variable is declared in a statement, and here's the syntax for declaring a variable. We use the keyword dim, which is short for dimension. That's a keyword. Then variable name is the name you, the programmer, give the variable, and then data type is the type of data that will be stored in that memory location. So dim, as, and the data type you choose are keywords. You have to use appropriate programming keywords, or you'll get a compiler error. Variable name is not a keyword. That is, within reason and using some rules, that's the name you give the variable. So here's an example, the last line of text on this slide, well, not the copyright, but the last line, dim int length as integer. Let's dissect that. Okay, dim, we're declaring, okay? We're declaring a variable. We're going to call it int length. It's an integer that obviously holds the length of something. As is a keyword, integer is a keyword. This variable will hold integers. Integers are whole numbers, 1, 27, 365. It will set aside some amount of memory for this particular variable. And from this point on, we can refer to that memory location using the name we gave it. And in this case, it's int length. You can also declare multiple variables of the same type in one dim statement. So in this example, we're declaring 3 integers using dim, int length, they're separated with a comma, int length, comma, int width, comma, int height as integer. Now, when we declare these, we're not giving them an initial value. That's a separate process. That's called initialization. Now, this one line of code can also be accomplished with 3 separate statements. Dim int length as integer, dim int width as integer, dim int height as integer. So you can save yourself some time in typing if you're going to declare multiple variables of the same type. You can do that in one line with one dim statement. There are some basic rules for names of variables. The first character of a variable has to be either a letter or the underscore character. It can't be a special character, a digit, a numeric digit. Subsequent characters may be a letter, underscore, or a numeric digit. Variable names cannot contain spaces or periods or any other kind of special characters, the question mark, etc. And also, you cannot duplicate any of Visual Basic's keywords as variables. You'll get an error when you try to do this. If you try to declare a variable called 1, the digit 1 length, you'll get an underscore. You'll get a compiler error. So that's where IntelliSense will help a beginner programmer not make mistakes. Now let's talk about naming conventions for variables. Although you can, within reason, name a variable almost anything you want, following the rules that we just went over, it's not a great idea. If you decide to, let's just say you own 100 cats, that would be weird, but you own 100 cats and you know the name of every cat, and you're writing a program and you decide to just start reeling off variables, declaring variables and naming them after your cats. And the program you're writing has nothing to do with cats. Well, that would be inappropriate. It wouldn't be illegal, wouldn't cause any errors, but it just wouldn't be intuitive. So I'm going to introduce some naming guidelines that I'm going to ask you to follow. Each data type has a recommended prefix in lowercase that begins a variable name. So for example, integers would have int, strings would have str, floats would have whatever. So the first letter of each subsequent word in the variable name should be capitalized. This is also called camel case. So here is using this guideline, here is a name for an integer variable that holds the number of hours worked. Obviously, it's a payroll program that would be, well, one would think it was a payroll program used. String last name, a string variable, which is a set of sequential characters. So that would be a string that holds the last name of the user. Okay, so far we've covered declaring a variable. That sets aside space in memory to hold specific data type. Before you can use that variable in an expression, we have to initialize it. We have to give it an initial value. So we can do that several ways, but an assignment statement is used to set the value of a variable. So let's take this example on this slide. We want to store the value 112, which is an integer, in the memory location identified by int length. That's called the identifier. We simply use the assignment statement int length equals 112. Now let's dissect that. That's not an equivalence statement. What it's saying is take what's on the right of the equal sign, which is the assignment operator, and store it or assign it to the variable on the left-hand side. You have to think of it in that context because later we're going to talk about equivalence and it's different than assignment. So if we'd like to assign the string, the literal string, good morning, followed by the contents of the text box text name to the variable string greeting, we can do that using concatenation. Remember, it's going to take what's on the right of the assignment statement, it's going to resolve that. In that particular case, is going to be good morning space and the string held in text name.text. Assignment changes only operand to the left of the operator. The operand on the right does not get changed. This slide shows some visual basic data types. This is the data type we can declare an integer as. So it goes after the as statement. Byte, short, integer, long. We're going to get into these. They're all integer types. Floating point, which means they have a decimal place in them. They're not a whole number. Single, double, decimal. Other data types. A Boolean is a variable that only has two states, true or false. A char is a single character, any character on the keyboard. A string is a sequential grouping of characters, and like hello world, that was a string. And a date, which holds a date. We're going to drill down on these in more detail in a few minutes. So let's cover the four integer data types. These are data types, variables that will hold a whole number. They cannot accommodate a decimal place. Okay? A byte, BYT, unsigned integer from 0 to 255. Short, or assigned integer means positive or negative, from negative 32,768 to 32,767. An integer, negative, you say it. I guess it's 2,147,483,684 to, there you go. Well, why wouldn't we use long for everything? Because each one of these requires more space in memory. So, for example, the pin in the ATM program, let's just say for the sake of this conversation, I know pins are 4-digit. Let's just say we have a 3-digit pin in our program. Well, we wouldn't want to use integer or long because that would take up more memory than we would ever possibly need. So if you tell the user, select the pin from 0 to 255, 000 to 255, then you're fine. Or let's just say we're going to declare an integer to hold a person's age. I don't know about you, but I've never met anyone that was 255 years old. I think the record is somewhere around 140, and that was an anomaly. So if you need to declare a variable to hold a person's age, then a byte would be perfect. And I've never met anyone less than 0. Not their age, but I'm not going to go there. Thanks. Up next, floating point data types. These are for values that have a fractional component or a decimal place. The most frequently used is single, and can accommodate values between 10 to the 38th plus or minus with 7 decimal points, positions. Double, huge range, 10 to the 308 plus or minus. And then decimal, 10 to the 29th plus or minus. Double, sometimes used for scientific calculations. Decimal is often used in financial calculations that involve currency. Here we have some other common data types. A Boolean typically use a variable naming prefix as BLN, holds 2 possible values, true or false, that's it. Char, variable naming prefix CHR, holds a single character. String, variable name prefix is STR, holds a sequence of up to 2 billion characters. Good luck with that one. Date, variable naming prefix is DAT or DTM, user preference, and it holds a date and or time information. We'll talk about formatting of dates later in the class. A string literal is enclosed in quotation marks. And so the following code assigns the name Jose Gonzalez, the string Jose Gonzalez. And I want you to understand that every letter, including the space, is part of the string. So that's not considered 2 words. It's just one continuous string. And the computer doesn't know or doesn't differentiate between the E at the end of Jose and the space between the E and the capital G. So first we declare a string variable, dim string name. String name, it uses the guideline I gave you earlier, but that is user definable, programmer definable. So dim string name as string. That sets aside the memory location. So we've declared space in memory, but that memory location holds nothing. It's undefined. Then, in the second line of code, we are initializing the string name variable. And we are using the assignment operator to assign the string Jose Gonzalez to the variable. So now, after those 2 lines of code, we have declared or set aside memory, a location in memory to hold a string, and we've stored a string in that variable location. Okay? Empty string can be coded as just 2 consecutive question marks. There's not a space in between those 2. That's quotation mark, not question mark. 2 consecutive quotation marks. There is not a space between those quotation marks. Or we can use the special identifier string.empty. String name equals quotation, quotation. Same thing as string name equals string.empty. Next, on to a somewhat more sophisticated data type, the date data type. Date variables can hold the date and the time, or both. you can assign a date literal to a date variable using the following syntax. Dim, obviously we're declaring. Dim, DTM birth, that is a name selected by the programmer. That is not a keyword, as date. And then, so that sets aside or declares memory location. DTM birth equals pound 51/2010 pound initializes the memory location. So a date literal is enclosed within the pound signs, symbols. Here's some examples of valid date literals. 12/10/2010, 8:45:00 p.m., or both, 10/20/2010, 6:30 a.m. All of those are valid values that can be stored in a date variable. This slide references tutorial 3-3, which I would like you to have already completed. If you haven't, stop here and go to your textbook and complete tutorial 3-3. It shows how the contents of a text box get assigned to a string variable. And I go over this extensively in the video I posted in the timeline for this session. So take a look at that. We declare a string variable called string full name in the event handler. And then we take the text property for text first name. We concatenate it with a string that contains just a space. And then we concatenate it with the text last name.text property. We assign all that to the string full name variable. Then the last line of code in that event handler is to assign the value stored in the string full name variable to the text property of the label full name. Take a look at the video I posted. I just posted a video in this timeline session that demonstrates how to declare a variable using IntelliSense. And you know, as you enter a line of code, let's just say it's a dim statement. You type D, and then you see the drop-down box with all of the keywords that begin with D. You type in I, you see all the keywords that have DI as the first two characters, and you just press the tab. You highlight dim, press the tab, and you go on to the next character. But I'm not doing it justice here. Please watch the video, and I demonstrate how to declare a variable using IntelliSense. It's very good. Well, I think it's very good because I did it. When a variable is first created or declared, Visual Basic does assign a default value, but I would not count on that. That's not a good practice. You don't want to just declare a variable and then start using it. You want to initialize it. Numeric types are given a value of 0, Boolean types given a value of false, string types are given a value of nothing. Dates default to 12:00 a.m. January 1st. 1. That's not 2001. That's 1 BC. So it's good practice to initialize the string variables, even if you want them just to be empty. Because a string variable with nothing will cause an error if you try to use it. You can also combine declaration of a variable and initialization of that variable into one line of code. And here's an example. We're declaring and initializing an integer variable called int months per year using the line of code you see at the bottom of this slide, dim int months per year as integer equals 12. So that sets up, declares the space for that variable in memory and assigns the initial value of 12. The next topic, scope of a variable, is somewhat complex, especially given this point in the learning experience, but we'll give it a try, and I'll continue to emphasize and further describe what scope is. Scope refers to the visibility of a variable and where it can be accessed within the program. Variables that are declared within a procedure, and an event handler would be a procedure, are called local variables, and they observe the following characteristic. The scope, its visibility, usability, its access begins where the variable is declared. So on the next line after it's declared, it can be referenced. And it extends to the end of the procedure where it was declared. However, the variable is not visible outside of the procedure. And you cannot declare a variable twice in the same procedure. However, and it's not great form, you can declare the same variable name in two separate procedures because they're two local variables and they actually get treated as two separate memory locations. But we'll talk more about that moving forward. Next, we're going to cover the contents from Chapter 3, Section 3.3, Performing Calculations. As you probably guessed, most computer programs have to perform calculations and yield results. And we've been leading up to this with the introduction of variables and assignment statements. So let's get to it. Here's a list of the common arithmetic operations and the Visual Basic operators used for those operations. Okay, so plus, as you might have guessed, is addition. The dash subtraction sign is subtraction. The asterisk is multiplication. The forward slash is division. And the caret, I believe that's called the caret, is exponentiation. So let's see how these are used. Let's take a look at some assignment statements. First one is addition. Okay, we have a variable on the left, double total, which is most likely a double, which means it is a variable that can store a value that has a fractional or decimal component. On the right-hand side of the equal sign, remember the equal sign is the assignment operator, is what's called an expression. And that expression is an addition of two variables that are double. So it's going to take the value stored in double price, it's going to add it to the value stored in double tax, and it will resolve the expression. In other words, it will come up with an answer, and then once that expression is resolved and the value is generated as the answer, then that answer, that value, is assigned to double total, the value of the variable on the left-hand side of the assignment statement. Subtraction, multiplication, division, exponentiation, just in case you're not familiar with that. This would take the value stored in double side and raise it to the third power, cube it. Resolve that, and it would assign the value, the answer to that mathematical expression. Assign it to the variable double cube. Visual Basic has a special operator for integer division. Most frequently, when you divide two integers, you don't yield a result that's an integer. If you, for example, 1 divided by 3 yields a decimal value, 0.333, repeating, or 1/3 as a fraction. So the backslash is used for integer division. and it divides one integer by another, the result is an integer created by discarding any remainder from the division. Excuse me. So if calculating the number of hours in a given number of minutes, we would take int minutes \60. If int minutes is equal to 190, this calculation will result in the value of 3. Remember, 180 divided by 60 is 3, but 190 divided by 60 is going to be 3 point something. Anything beyond, including the decimal place and to the right, is discarded. It's important to know that it's not rounded, it's just discarded. And because integer division doesn't round up, or doesn't round in the way that we typically think of rounding, we have the modulus or mod operator. And it can be used in place of the \# operator to give the remainder of a division operation. So for example, int remainder 17 mod 3. So 3 divides into 17, 5 with a remainder of 2. 3 times 5 is 15 is a remainder of 2. So int remainder will hold 2. Double remainder, 17.5 mod 3. 3 goes into 15 with the 2.5 remainder. So double remainder, if used with mod and a decimal value, will yield a decimal value, that decimal answer. Often, when programming, you want to insert the date, the time, or the date and time. So Visual Basic has 3 keywords that generate the current date, the current time, or both the current date and time. And those keywords are now, which generates the date and the time of day, which generates only the time, and today, which generates today's date, or the date in which it is generated. There are some examples in the table listed in the center of this slide. DTM current equals now, DTM current time equals time of day, DTM current date equals today. Each of the variables on the left of those assignment statements must be declared as data types in order for them to hold the date and time, the time, or the date only. Over the next 2 slides, we're going to cover combined assignment operators. And these are used when you want to change the value in a variable and assign the result back to that variable. You know, the example given at the beginning of the slide is int value equals int value minus 5. So if you want to decrement int value by 5, that line of code will take, on the right-hand side, it'll take the value of int value minus 5 from it, or subtract 5 from it, resolve that. So let's just say assume int value is 10. So 10 minus 5, that will yield 5, and that will be assigned back to int value. So int value will have a new value. Other examples, x equals x plus 4, x equals x minus 1. In counters, if you're decrementing the counter, if you start at 10, and the counter is called int counter, you want to subtract 1 each time until it goes to 0. And we're going to get into that ad nauseum moving forward. The next slide will show you how to do this in an abbreviated statement or a shortcut. I first learned these combined assignment operators, I would say 1993. I know what that makes me. I always laugh when I have students who tell me, I wasn't born then, Professor Mink. And I say, so what? Just kidding. Anyway, the plus equals operator allows you to shortcut the statement x equals x plus 2 as x plus equals 2. Now, you don't have to use these, but they are nice, and they do give your programs a professional look. Minus equals allows you to take x equals x minus 5 and express it as x minus equals 5. Asterisk equal, multiplication equal, divide equal, int divide equal, and concatenate are all part of the combined assignment operators, which are shortcuts. Once again, your code is not incorrect if you use the longhand equivalent, such as x equals x plus 2 instead of x plus equals 2. Okay, I'm going to start off telling you what I tell every single student in every programming class I've ever taught. Parentheses are your friend. There's all these cute little rules called like PEMDAS, please excuse my dear Aunt Sally. But parentheses trumps any of those rules. But the order of the operator precedence dictates the order in which operations are performed. And if you don't use parentheses and you have these arithmetic operators in an equation or an expression, exponentiation gets resolved first, then multiplication and division, then integer division, then the mod, and then addition and subtraction. Okay, so if you don't use parentheses, you're at the mercy of this order of operation. However, parentheses trumps all this. Anything within parentheses gets executed first. So parentheses are your friend. Trust me. Here we have a slide showing operator precedence and two examples of expressions that yield significantly different results just by moving one of the operands. And you know, I don't want to make this more detailed than it is, but if in fact you wanted to divide everything on the first line by 2, put everything except for the divide by 2 in parentheses, and that will happen last, regardless of addition, multiplication, or whatever. So once again, I'm not going to dwell on this, because if you just put parentheses in your expressions to control the order of operation, you won't have to deal with these rules, and you won't have to remember them. I have 4 college degrees, and I can't remember these rules. Because I use parentheses, I don't have to. So that's all. Let's move forward. Rant over. See ya. So, like I said, use parentheses to group components of an expression that you want resolved before others. And so here's the example the author gives. We have an expression on the right-hand side of an assignment statement that will be assigned to double average, int1 plus int2 plus int3 divided by 3. That will basically, no, that will sequentially divide int3 divided by 3 and then add that result to int1 and int2. Well, if the intent was to add int1, int2, and int3 and then divide the sum of those 3 ints by 3, okay, you must use parentheses in order to get that desired result. You're really beating this horse to death. One of the mistakes I often see students making at the beginning of their programming experience, learning experience, I should say, is to use algebraic notation for mathematical expressions, such as 2xy describes the value 2 times x times y. Well, in Visual Basic, you can't do that. Visual Basic requires an operator for any mathematical operation. So 2 times x times y would be 2 asterisk x asterisk y, assuming x and y have been declared as variables. Here's a table that gives several mathematical expressions, the operation, and the equivalent expression in Visual Basic. Next, we're going to move on to the material in section 3.4, mixing different data types. And it's quite important that you understand how this works, because any text box you use to solicit input from the user comes in as text, even if and then we need to convert it to an and, a double, or whatever other data type. And we're going to show you the operations that perform those conversions quite soon. Stay tuned. First topic is implicit type conversions. That means a value of a specific data type, like an integer, can be assigned to a variable of a different type, let's say a double. And there is what's called an implicit type conversion that happens. And that's an attempt to convert to the receiving variable's data type. A widening conversion typically suffers no loss of data, which means converting an int, such as 5, with no decimal component, no fractional component, to a double is called a widening conversion. So here's an example. Dim double val as double equals 5. So we're taking 5, which has no decimal point, so that's an integer, and we're assigning it to a double in a declaration statement. So we're both declaring double value when we're giving it an initial value of 5. That 5 gets converted to 5.0. A narrowing conversion often loses data. So here's a second example of converting a decimal, a number with a decimal or fractional component, to an integer. Dim int num as integer, so we're declaring int num as an integer variable, which means it can't hold fractional components, and we're assigning it an initial value of 12.2. Well, what that means is 12.2 is being assigned to an integer. Int num, because it's a narrowing conversion, int num becomes 12. Remember, an integer cannot hold a fractional component or a decimal, so it just truncates that 0.2. A better example would have been dim int num as integer equals 12.9. One would think, oh, it will just round it up to 13. No, that's not the case. It will not round it. It will just ignore the decimal. So 12.9 narrowed, given a narrowing conversion to an integer, will yield 12, not 13. Next topic, option strict. Option strict is a Visual Basic configuration setting. Only widening conversions are allowed when option strict is set on, which means you can assign an integer to a double variable, but not vice versa. Okay? A double cannot be assigned to a single can be assigned to a double, a decimal cannot be assigned to an integer, etc. Option strict on is recommended to help catch errors. If you turn it off, you can get into a situation where I just mentioned, where, remember, no rounding takes place in a narrowing conversion. Here's an example of a runtime error caused by a type conversion. Here's the statement, dim int count as integer equals, and then a string, ABC 1, 2, 3. This is obviously a narrowing conversion. With option strict on, the statement will not compile. If you turn option strict off, the statement compiles, but string ABC 1, 2, 3 will not convert to an integer. And a runtime error, which is called a mismatch, occurs when this statement is finally executed. This is a bad thing. You don't want to do this, and you want option strict on to catch these types of programming errors. Visual Basic supplies a set of literal type characters which you can use to force a literal to assume a data type other than the one that its form may indicate. And this table shows the character which is not part of the name or not part of the value, which gets appended to the value in an assignment statement to force the value being assigned to assume the data type indicated by the literal. This slide shows some examples of using literals. The literal for an integer is I. So for example, look at the third column where we're assigning the literal value 347 to a variable j that that had to have been declared as an integer. But to make sure that 347 is resolved as an integer, we put the I after it. The next example, decimal, is a little bit better example in my opinion. So 347 looks like an integer, but we want to assign it to x. And we want it to be assigned as a decimal. So we use the letter D. In many cases, this is not necessary, especially in a widening conversion, but it would help in a narrowing conversion. Next, we're going to discuss the concept of a constant. A constant is a value, a variable containing a value that should not change. So for example, pi, which is a mathematical constant, and if you wanted to represent pi as 3.14159, you would declare a constant variable. And you would, by declaring it as a constant, which we're going to see on the next slide, the programmer would not be able to change the value stored in that variable throughout the program. So here's an example. Double total times equals 1.06 is the same as double total equals double total times 1.06. We're assuming it adds 6% sales tax. 6%, the sales tax rate will not change, okay? Or if it does change to 7%, you got to go into the program and find every occurrence of 0.06 or 1.06 and change that. If instead of the literal value 1.06, we used a named constant, and we declared that as a constant, which I'm going to show you how to do in the next slide, and the tax rate changes in that particular state for that program, you just need to change the value assigned initially during the constant's declaration statement. Hold on and we'll take a look in 1 second. So here, we declare a variable, just like we've been declaring variables so far, except we add the keyword const, C-O-N-S-T, to the beginning of the declaration statement. And that means that within the program, we cannot assign a new value to double sales. It cannot change. So here's the syntax, const, double sales, tax rate as double equals 1.06. So then we use, and as you can see, const is used instead of dim, but it's the same thing. We're just declaring a const. Well, it's not the same thing. We're declaring a const. You must initialize the value when it's declared using const. You can't say const double sales tax rate as double. You'll get an error. Okay? So now, when we want to add sales tax, double total times equals double sales tax rate. That takes double total and multiplies it times the double sales tax rate, which is 1.06, and assigns the value back to double total. If we have 10 occurrences of the sales tax rate in a program, and the sales tax rate for that particular state changes, then we just go back to the declaration, const double sales tax rate as double equals 1.06, and we change that, let's say it goes to 6.5%. Then we would change that to 1.065. And everywhere in the program that constant is used would be 1.065. Hope this helps. Next topic is explicit type conversions. And we use a function that performs some predetermined operation and provides a single output. And within Visual Basic, there are a set of functions that permit narrowing conversions with option strict on. These functions accept a constant, variable name, or arithmetic expression and returns the converted value. This is very useful in converting input that was solicited from the user via a text box and converting it to the appropriate data type needed within the program. Hold on and we'll cover more in the next slide. If you want to convert a value from a double to a single, or a single to an integer, or a long to an integer, you must use an explicit type conversion. Boolean, date, object string, and numeric data types require different sorts of values and require conversion functions. Remember, I told you if you try to assign a double to an int variable, it truncates the decimal component. So 12.9 would just become 12, and that's typically not very useful. However, we do have explicit type conversion functions, okay, that provide a rounding function, or rounding capability, I should say. So the first one I want to cover is cint. Cint is a function, and next to it, within parentheses, is the expression being converted to an integer. So in this particular case, we have a line of code. Int count, we're assuming is an integer. It's been declared. And we're assigning it the value cint with the argument 12.4. Cint is the function. The argument is the value being passed to the function, and that will be converted to an integer. It's converted, in this case, to 12. However, if we pass 12.5 to cint, it does the rounding, and it rounds up to 13 and assigns it to int count. CSTR converts an integer value to a string. So if we want to put 26 as text, not as the number 26, as the character 2 followed by the character 6 in a string, which is different, we can use the cstring, convert the string, and assign it to a string. cdec, cdec, converts a string to a double. cdate converts a string to a date. Now, obviously, it has to be in the appropriate format to be a date. Okay, if that were 9a/14d/abcd, you'd get an error because that conversion would not be successful. When you solicit input from the user via a text box, it comes in as text, as a string. So if you're asking the user to enter a numeric value, either an integer or a decimal, you should immediately convert it using cint to an integer, cdouble to a double, cdec to a decimal, etc., etc., etc. Okay? This table shows the most commonly used conversion functions. The syntax is real simple. The function name, and then in parentheses, the expression that it's going to convert to an integer, double, date, decimal, etc., etc., etc. Now that expression can be a literal value. It can be cint in parentheses 12.4. It could be two variables added together, and then their sum would be converted. Their sum would be evaluated and then converted to an integer, etc. And you'll see as we start to write programs how these are used and how useful they are. This slide shows a full list of the conversion functions that are available in Visual Basic. And I'm not going to recite them to you, but take a close look so that you know they're available. And we'll use, we'll probably use half of these in this class. As I mentioned previously, the conversion has to be valid. The value passed to the function has to be valid. So here's some invalid attempts at conversion that will generate a runtime error called an invalid cast exception. So for example, we're declaring using dim a variable called double salary as a double, and we're assigning it the result of a function call to convert double, CDBL, and we're passing it XYZ. Well, XYZ in no universe can ever be converted to a double, which is a numeric value with a fractional component. So that is going to generate an invalid cast exception runtime error. Second example would be we're declaring using dim a variable called dat hired as a date, and we're using the cdate function to convert 5/35/2014. Once again, there is no month that has 35 days. So that is an invalid date. And that will generate a runtime error that will generate an invalid cast exception runtime error. I hope this clarifies the statements I made earlier about the value being passed to the conversion function has to be valid for the type you're trying to convert it to. Okay, we're getting close. This is the last section from the textbook that we're going to cover in part 1 of this chapter's lecture. And we're going to discuss formatting numbers and dates. Every Visual Basic data type has a method called toString, and it uses the form variable name.toString. So what it does is it converts whatever value is stored in variable name when it's called to a string. A string is text, not numeric. So here's an example. We're declaring a variable using dim. Its name is number. And we're declaring it as an integer, and we're initializing it with the value 123. Then we're changing the text property of label number, and we're assigning it number.toString. That text property will hold the string 123, not the value 123. Very different. Remember, a string is a sequence of characters from the keyboard. 123 can be stored as text, as a string, versus the numeric value 123, which has positional value in the ones, tens, and 100ths column of that numeric value. Now we're going to delve a little deeper into the toString method, and typically I find students, many students, get frustrated or confused by this. The toString method can also pass an argument in the form of a format string. And that indicates how you want to format the string. So here's an example. We're declaring, and follow this closely, we're declaring using dim a variable called double sample as a double. Okay, so that can hold a value with a fractional component. We're declaring a second variable using dim called string result, and that's being declared as a string, so a sequence of characters. Then we're assigning the numeric value 1234.5 to the variable double sample, which is declared as a double, so that's an appropriate assignment. Then we're going to take double sample and convert it to a string in the currency format. So that's going to have $1, 234.50. We're going to convert it to a string in currency format and store it in string result. And I would imagine something like this would be, I know something like this would be done to then store string result or assign string result to the text property of a label and display the currency value, $1,234.50 in that label. Here's a list of the format strings that can be used with the toString method. And upper or lowercase n, the format includes commas and displays 2 digits to the right of the decimal place. F, capital F or lowercase f, is fixed point format, 2 digits to the right of the decimal place, but no commas. E, capital or lowercase, is exponential format, displays values in scientific notation with a single digit to the left of the decimal point, and the exponent is marked by the letter E. And the exponent has a leading plus or minus sign. C is currency format. We just covered that. Includes the $, comma, and 2 digits to the right of the decimal. And P is the percent format. Multiplies the number by 100 and displays it with a trailing space. You can also add an integer to the end of the format string to specify the number of digits to display to the right of the decimal point, also called decimal precision. And obviously rounding occurs when you're displaying fewer decimal positions than the number contains. Here's a table showing the numeric value, the format string, and then the toString value returned. So 12.3, if you put N3, will give you 12.300. 12.348, N2 will generate 12.35. And I'm not going to read all of them to you. You can review them on your own and see how that works. With integers, you can control the minimum width. And if that exceeds the minimum width necessary to fully display the value, you will add leading zeros. And this is done by inserting a D. Here's a table with some examples. If you just add a D after the format string, you'll get 23. If you add D4, okay, you'll get 0023. If you add D2 to 1, the literal 1, you'll get 01, etc., etc. Pretty simple. This slide, which is the last slide in this lecture, details how we format dates and times using the toString method, and what what value format string gets passed to the toString method. And lowercase d is a short date, And there's an example. Uppercase D is a long date. T is a short time. Capital T is a long time. And F is the long date and time. Now, I'd like you to immediately, if you haven't already done this, complete tutorial 3-8. I've put a video of this tutorial running and me going over some of the key learning outcomes from this lecture regarding formatting dates, times, and numeric values. It is a very important tutorial for you to complete and understand. And of course, if you have any questions, don't hesitate to ask me. You know how to get a hold of me. Thanks for watching this video. Have a great day. I'll see you in next week's lecture. Well, actually, I won't see you at all. You'll hear me, and we will correspond asynchronously. Okay, thanks. Take care.